Okay, welcome to chapter 3. So in chapter 1, we introduced the ideas of statistics and gave lots of definitions of words about collecting data and et cetera, et cetera. And we looked at the idea of wanting to know something about a population, then collecting a sample from that population, looking at the information by collecting a statistic or some data from our sample, with the idea that we would then somehow do some analysis we hadn't discussed yet, and then try to make inferences about the overall population. And we began to look at what we do with the data in chapter 2. We looked at how to organize the data, and we looked at creating frequency distributions, graphs like histograms, dot plots, box plots, things like that. So now in chapter 3, we begin looking at actual analysis of the data, and there will be some formulas and numerical calculations involved. So the title of chapter 3 is Describing, Exploring, and Comparing Data. There's 3 sections in this chapter: measures of center, measures of variation, and measures of relative standing in box plots. So in the first section, we're going to talk about measures of center. So what's the key concept? The focus of this section is to obtain a value that measures the center of a data set. In particular, we present measures of center including mean and median. And again, these words are in bold because they have yet to define exactly what mean and median are. Our objective here is not only to find the value of each measure of center, meaning there will be a calculation to determine that value, like a formula, but also to interpret those values. So specifically, I want to point out from the get-go that they will begin to show you a lot of notation and formulas and show you hand calculations. But from the very get-go, I also want to suggest that we focus on using technology to find these values for us when at all possible. There will be some cases where you need to do some hand calculations, but those should be fairly minor if we're focusing on using technology to help us, and nothing that you couldn't do quite quickly on a standard like calculator, scientific calculator that you'd get at Walgreens or Walmart for $10 or something like that, or just use on your phone. All right, so having said that, let's go into looking at what these calculations are. So the first and most commonly used measure of center is, well, in general, the description of a measure of center is a value at the center or the middle of the data. And then we'll look at the first one in a second. I'm getting ahead of myself. So what do you mean a value at the middle of the data? And so there's a couple of ways to do that. But if you think about a data set as a big pile of numbers, then it very easily makes sense right away to say, well, what was the smallest value you got? And then what was the largest value you got? The minimum and the maximum are very quickly clear and obvious things to look at. But you don't have to calculate anything to see what they are. You just observe that the smallest and biggest values are what you see. So to find something in the middle, we have to then talk about how to do that. What would a value representing the middle be? And we're actually going to look at different ways to do that. Now we'll get to the first one. The most common one is the mean, or the arithmetic mean. So it defines this as the set of data, the measure of center found by adding all the data values and dividing by the number of the data values. So the more colloquial term that people use for this is the average value. Now, specifically, the word average in the real world has all kinds of different meanings and connotations and interpretations. So when we're working in statistic, the general practice is to try to avoid saying average when the idea that you're talking about is the mean. Because the mean is a very clearly defined, add them up and divide by how many there are, where if you say for something like, well, this is a very average color of a car. Obviously, that's not talking about the mean because you can't add and divide colors. And so the word average has such a broad use in common vocabulary use, common vernacular, that you want to recognize that the book is going to make an effort to stick to the word mean value. But mentally, as you're getting used to that, you can just think when you see the word mean that it's the average of the numbers. So as we look at the different ways of talking about the sort of central value of a data set, like the mean, with each one, we're also going to talk about the properties of this kind of a result, of this kind of a calculation. And there are going to be some themes that they look at in how to examine, when you're looking at a particular statistic for a measure of center, what kind of properties this statistic value has, specifically in relation to what extreme values will do to that value and other things that we'll consider here. So what do we have here? Important properties of the mean. Sample means drawn from the sample population tend to vary less than other measures of center. So we haven't even talked about other measures of center yet, but one of the values about the mean is that when you have data varying around in different ways, as data will do, that the measurement of the average value of numerical data, the mean value of data, is that it doesn't vary around as quickly or as easily depending on extreme values and things like that, compared to other measures of center. And we'll look at examples to try to illustrate this. It says the mean of data set uses every data value. So right away, it's helpful for us to understand why these things might be important by trying to compare and contrast. So I'm going to go outside of the mean for a second and introduce another type of way of measuring the center of a data set so that we can at least compare it with the mean and get an idea of why these properties are of importance. So another way you could talk about the middle of a data set is to just say, well, what is halfway between the minimum and the maximum? If I just took the average value of the max and the min, if I just split the difference or went halfway between the max and the min, that's called the mid-range value because it's in the middle of the range from top to bottom. So let's say I had a data set and the minimum value was 0 and the top value was 100. Then the mid-range or the middle of that range would be 50. So you might say, oh, so the middle of the data is 50. Well, the mid-range is. But let's say that I have a whole bunch of those and 99% of the values is 0 and only 1% of the values is 1. Well, if I averaged all of those out, I'd get an average, 1% of the values was 100. If I have 1% of the values at 100 and all the rest at 0, then the average will come out to be 1. So that would really tell you that, well, even though there's a few cases where there's 100, almost everything is 0, and that there's so much of it is so low that the average ends up being 0. So notice you have a mid-range of 50, and you have a mean value of 1. And so when they say the mean of the data set uses every data value, you could see, for example, that when you have an average of 1, that it tells you that if you look at all the data, most of it is very, very low, especially if you consider that the range is 0 to 100. How can I have a range from 0 to 100 and have the mean value be 1? Well, because most of the data is really down there next to 1. Whereas if I just do the middle of the range, I'm only using 2 of the data values to find out what the middle is. I'm only using the smallest and biggest data value and splitting the difference between those 2. And so it doesn't tell me where all the rest of the data is. So when you have a calculation that does actually involve using every data set value, then it doesn't leave anything to be ignored. And in some way, it might be considered, in some purposes, a proper reflection of the data. A disadvantage of the mean is that just one extreme value, an outlier, can change the value of the mean substantially. Using the following definition, we say that the mean is not resistant. The following definition, meaning the definition of resistant, is about to follow. So let's get that out of the way, and then let's try to discuss these points a little bit to see if we can help make sense of them. So now they're defining resistant, and again, this is a word used when discussing properties of statistics, specifically measures of center like the mean value. A statistic is resistant if the presence of extreme values or outliers, as we briefly alluded to in chapter 2, does not cause it to change very much. It's resistant if it's resistant to being changed by outliers, is the bottom line for that. And they just described for the mean that it is a disadvantage of the mean because it is not resistant, meaning that it is influenced heavily by a small number of extreme values, meaning that it is not resistant because its resistance if it does not cause it to change very much when you have extreme values. Whereas the mean is changed a lot by extreme values and is not resistant. So we'll flush this out a little bit. I want to get to our next measure of center because then we can really compare and contrast specifically the idea of being resistant. So I'm going to show you that they do start dumping notation on you and provide formulas. And I'm not going to try to go into the depth of the notation here because our time is better served in a group talking about the ideas than letters. But there will be something to look at. And if you are feeling overwhelmed by that, please see me in office hours and we can go into whatever level of detail you need to become clear and hopefully help you not be overwhelmed by too many letters being used. And one of the reasons I want to kind of skip over this is because we're not going to use really the formulas. We're going to use technology like StatCrunch to do the calculations for us. Now, sometimes looking at the calculations and the formulas does help further the understanding of the value that is being calculated. But also it quickly becomes burdensome for many students. And so I'm going to allow students to choose a little bit for themselves how much they want to dive into the use of the formulas and how much they want to avoid it. All right, so they do give an example of the mean. I do want to move on quickly because we have 40 slides. We won't get to all of them, and I want to go to the next measure of center. But just to see in action what the mean is, what they said was you add up the values and divide by how many there are. So they said they had some airport speeds. And in this case, they took 5 of them. And so they show adding up the 5 values and then dividing that total by 5. And that gave a mean value. So then a little bit more discussion about the mean. And here's their reference to the word average that I talked about earlier. Never use the term average when referring to a measure of center. The word average is often used for the mean, but it is sometimes used for other measures of center. The term average is not used by statisticians. The term average is not used by the statistics community or professional journals. So they're just trying to warn you here. So, you know, if you use average or like to think of the word average because you're already very comfortable with that and that's working in this context, don't let them shame you out of that. But certainly as you get more accustomed to the idea of what the mean value is mathematically and how the number represents something in statistics, it'll get easier and easier to not think of using the word average in that context. All right, so here's number 2. Median. The median of a data set is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. So the middle value, the value that's sitting in the middle if all the data values were lined up in a row from smallest to biggest. So notice this is not the mean. The mean is where you add them up and divide by how many there are. but it does use all of the data values to determine which one should be in the middle, because to be in the middle, you have to see where you are compared to all of the rest. If, for example, in my crazy example of having a bunch of data values where most of them were 0, but like the top 1% of the data values were 100, well, then if I lined all of those up, there'd be a whole bunch of zeros, and then at the end there'd be some hundreds, so the one in the middle would be a 0. So in that case, the middle or the median value would be 0, whereas as I mentioned before, the mean value would be 1, and the mid-range value would be 50. All right, so why would we want to know the number that's in the middle instead of the average, or better said, mean value of the numbers? What's the difference between those, and what properties does the median have, since we just were discussing what properties the mean value has? Important properties of the median. The median does not change by large amounts when we include just a few extreme values, so the median is a resistant measure of center. And we just were discussing how the mean value is not resistant. The median does not directly use every data value, so it doesn't actually use the value itself. For example, if the largest values change to a much larger value, the median does not change. However, it does use them indirectly, because where you are in relation to those is what determines whether you're the median value or not. So for example, if we were looking at 100 data values and the top value was 1,000, and I calculated the mean value by adding up all the numbers, and I got some value like 200. Well, then if I increased my top value from 1,000 to 2,000, well, the mean value would go up, because when I added them all up, when I added up that top number, instead of adding in 1,000 to the total, I'd be adding 2,000 to the total. And then when I divided by 100, I would get an increase in my mean value of 10, because I added 1,000 to my total. And then when I divided by 100, 1,000 by 100 would give me 10 more. So if I added 1,000 to the highest value of 100 data values, then the mean would go up by 10. But if I had the same data value and I looked at the median, the one that was sitting in the middle, and the top one is way up there, I'll put it on the right, way up there on the right, there's that value of 1,000 at the very top. If the median value was, say, 200, well, then when I add 1,000 to the top value and it becomes 2,000, well, just the number on the top got bigger, but the middle position never changed. And the 200 that was sitting there in the middle didn't move position because of that. So that's what they're talking about, how the middle value, the median value, is not affected greatly when the biggest or teeniest values become more extreme than they were. It doesn't change the position of the middle very much. All right, so that is a whole lot for me to introduce. So let's see what their examples are, but pretty quickly we're going to try to wrap our minds around this by looking at alternate examples and coming up with some of our own. So calculations and notation, I'm going to skip that. And let's look example of median with an odd number of data values, so we can at least imagine the calculations. So if you imagine taking data sets and arranging them in order from smallest to biggest, and then looking at the ones in the middle, well, when you have an odd number, then there'll be one data value in the set that's sitting in the middle. So you can imagine in this case where they have these 5 data values, if they lined them up, you could just say line them up in order, and the one that's in the middle will be the median value. And it will make sense when there's an odd number of data values that there will be one sitting in the middle, because then there's an equal number on the right and to the left when you have an odd number. And then that number itself, that actual data value, is the median. Now, if you have an even number, well, then when you line them up, there isn't one number sitting in the middle, because right in the middle, you're between 2 values. So as they describe here and as they define, what you do then, if you have an even number, is you take the 2 values that are sort of each sitting on either side of the very center of the data, and you average between the two to get a number in between them, and then that's the median value. So in this case, dead center, let's see if I can draw, is right here. So if I draw this line here, we see that's the place where there's an equal amount of data to the right and to the left. And so then they took those two values in the middle and they took the mean value of those two by adding them up and dividing by 2. And then the number that they get, if it were in the list of data, it's not, but if it were in the list of data, it would fit right in between those two numbers because you split the difference between those two. So even though in this case, 23.8 is not one of the data values from the data list, it is a number which is sitting directly in the middle of the data values because half of the data values are bigger than that number and the other half of the data values are smaller than that number. All right, so then they're going to get to mode. But so let's pause here. The best thing we can do at this point is to look at these two primary measures of center, the median and the mean, and try to understand what they tell us and compare and contrast them a little bit. So let me offer up another situation where these values are often used and how you can imagine how the difference between them might be significant. So one of the ways that data gets analyzed in a macro setting, meaning on a very large scale setting, like across our entire nation, is income. As we mentioned earlier, there was, in the year 2020, a census was done, which is only done once every 10 years, where they try to collect information from the entire country, because they collect very important things that seem to matter a lot. And one of the things they collect is income. And of course, income is reported by supposedly everybody in the country because they're supposed to pay taxes and do that. Now, of course, maybe not everybody's included in that collection of data for a variety of reasons. But nonetheless, incomes of households is looked at a lot because decisions are often made based on that in governmental positions. And so you could sort of say, well, if you take everybody in the country, what is the mean household family income? So that would mean taking the household family incomes from all households in the country, adding them up, getting some huge amount of money, and dividing by how many there were, and that's the mean household income. So someone might say, okay, well, that's kind of a measure of the middle of the country's household income? Or is it? Well, again, we have other ways of measuring the middle and we want to compare and contrast to make sense of it. So let's compare it to the median household income. That would be if you took the household incomes of everybody in the country and lined them up from smallest to biggest, where is the middle of that list? Where is the household income where half the people in the country make more than that as a family income and half the people in the country make less than that as a family income? And which one is more important, and would there be a significant difference? Well, it turns out all the time whenever you do this, that the mean household income, where you added up and divided by how many there were, is always significantly higher, sometimes in excess of $10,000 higher per year than the median. So let's, can we imagine why that would be? Can we have a discussion, questions, comments about the idea of why would it be that the mean household income is higher than the median household income? And what does that say about those numbers and how they're telling us information about household income in the country? So having said that, let's open it up to discussion. Yes.
I'd say that's because there are some very large outliers on the very top that are bringing the whole average up.
Yeah, that's exactly right. And so to use the vocabulary we've just been introducing, the mean value is not resistant. So it's sensitive and can be pushed or moved by extreme values in the data set. So if you're trying to sort of imagine the middle idea of how much families are earning, and then you have one family like the Walton family or something like that, that earns, you know, many, many hundreds of millions of dollars. Well, when you add that to the total of all the money earned, that gets the whole average to increase. That causes the whole average to go increase, even though there's only one family out of the hundreds of millions that earned that amount of money. And if you have 1% making a bunch or 10% making a bunch, then that could cause the average to go up a lot. And therefore the average will kind of move away from at least where the middle value of household earnings really is. Whereas if you take the median household income, then you know whatever that amount is, that half the households in the country make more than that, and half the households in the country make less than that. And there's a very common misconception with the mean value. So if someone says the mean family income is $60,000, well, then people might think that the majority of people in the country make, you know, close to 60,000 or better. When actually it could be that 70 or 80% of the country makes less than that. Whereas when you give the median household income, if instead the median household income was given to, say, be $52,000, then you know that half the country makes less than that and half the country makes more than that. Questions, comments, discussions about that? So let's try this. Let's see if we can engage your imagination to try to have these definitions and these ideas start to make sense for you. And you can think about how these calculations and these statistics results would reflect on data sets that you are collecting. Can someone or everyone try to think of this, and maybe someone will offer up their example if they're willing. Can someone think of a situation or a data set that's actually specific in which the mean value might be lower than the median value? Is that a tough one? What does a data set need to look like? Thinking about distribution of data, chapter 2, so that when you calculate the mean value, you get a lower value than the middle value, the median value.
Well, I guess it would need to have like a bunch of super low outliers as opposed to like a bunch of super large ones.
Yeah, and let me just help with clarity. We don't need a bunch. That's the problem with the mean, is that if the values are extreme compared to the others, then even a few of them will cause a serious movement in the mean value, if that makes sense. But definitely if there's some chunk of them which are very extremely low compared to all of the rest of the data, that could move the mean to be below the median. Can we think of a real example where that might be something to consider? All right, so let me help because I know this stuff is new, but hopefully you're still trying to get your brains to get engaged and make this working information and not just passively trying to absorb it, because that's harder to understand it that way. So here's an example. Let's say you have some working industry like welders, and they're trying to look at sort of what kind of money per hour that their welding class is earning. And so they go around and they say, okay, and they talk to everybody who's a member of the group because they don't want to leave people out. And they say, all right, well, right now, what is your current hourly rate of pay? What are you making right now per hour? Well, it might be that if they collected that data, they see a chunk of people show up and say 0. And say, what do you mean you're making 0 per hour? And then you go to those people and they say, oh, well, I'm unemployed. So right now I'm making nothing. And then people will say, well, we don't want to count that. And they say, well, what do you mean? People who are unemployed aren't making anything. They're part of the group. They should be considered. So then you might want to say, all right, well, we have a portion, maybe only 5% of our group of working welders or welders who are trying to work who haven't been able to get a job, and they're putting down 0. But that's not really telling us that when they got a job, how much would they make? And so then there might be a discussion about whether they should be included or not, whether you'd want to use a mean or whether you'd want to use a median. Some people might say, we'll just not use those. We'll remove those outliers and not even consider using that data because we want to know when you are paid, how much you get paid. Or people may say, no, we don't want to know that. We want to include those people because we want to know sort of the basic idea of how much welders will make, and part of that time they may be unemployed. If we have 5% unemployed, that may be because welders are unemployed about 5% of the time, and that should be included when understanding and thinking about how much they're going to make. But maybe we'll use a median value so that those guys don't like pull an average rate of pay per hour way down, or a mean value. And maybe the mean value where these zeros are counted and drag it down ends up being $30 an hour. But if you use a median value, the middle value jumps up to like 40 or 50, because maybe that's more in the middle, including the zeros of a range of values that you would get. So I know that trying to think of examples puts the burden on students of kind of all of a sudden making something feel like a word problem. But we want to go there right away to understand the basic concepts of statistics. And we're trying to invest in that by taking some of the burden off of students of having to use complicated formulas and do those kind of calculations yourself, so that we have more time to think about the ideas and the meaning of these statistics. Questions, comments, discussions before we move on to our next measure of center? So the mode of a data set is the value or values that occur with the greatest frequency. Well, now that we've been looking at frequency distributions in table or histogram form or whatever, it's basically just the data value that occurred the most. Now, if we have to sort of think about what kind of situations that might provide, let's see, I think they discussed them here. So in properties of the mode, important properties of the mode can be found with qualitative data. So you don't, because you're not adding or putting them in order from smallest to biggest, you could have colors. So if you are trying to have a sort of think of the most common, remember most frequent kind of means most commonly occurring. Well, you can have the most common color, and that can have meaning. And so you can just say, well, we took a bunch of favorite colors and blue was the mode. It's the answer that people gave most frequently for the color that was their favorite. So that's valuable to recognize that a mode is a non-numerical, doesn't involve a calculation that's numerical, and so it can be applied to categorical data. A data set can have no mode or one mode or multiple modes. So that's where we have to think about actually tallying up a data set and trying to see what occurred most frequently and what could happen. So for example, what if all the data values only occur exactly once? Do we say that's a mode of 1 or a mode of 0? So that's what they're kind of getting at here. And what if 2 different data values tie for being the most frequent? What if blue and green both had the same number of responses for what the favorite color was? So in finding the mode, they'll discuss this a little further now. A data set can have one mode, more than one mode, or no mode. When two data values occur with the same greatest frequency, like maybe blue and green, each one is a mode, and the data set is said to be bimodal. Like bicycle, bi is a prefix for two, so bimodal means there's two modes. So if blue and green are both the most tied frequently responded colors, then you would say the mode is blue and green. So the mode would actually contain two values. It would be a set of blue comma green. When more than two data values occur with the same greatest frequencies, like if the tie is more than just two, then each is a mode. So you have a collection of modes. They're all modes if they all tie for being most frequent. And the data set is multimodal. Multi meaning just several. When no data value is repeated, so if we do have a tie because everything occurs just once, we say there is no mode. Questions, comments, discussions about that? So in this simple example, they give us a data set, and there's the value of 0.3 that occurs 3 times, which is the greatest frequency. 0.6 occurs a couple of times, but not 3 times. So the mode would be the value 0.3 from the data set because it occurred most frequently, and there would be one modal value. If instead you have a data set like listed here where the 0.3 occurs twice and 4.0 also occurs twice, and that's the max, then there are 2 modes, 0.3 and 4.0, and this would be an example of being bimodal. If the data set has all the frequencies occur only once each, then you just say there's no mode, meaning nothing was more frequent than anything else. So this gives us our top list of 3 measures of center, even though this doesn't really act like a measure of center, but it's usually thrown in with a summary statistic with the mean, median, and mode, maybe because they all begin with an M and are small sort of words. Mean, median, and mode are often 3 things of interest. Mode is not really a measure of center because we don't know if the thing that occurred most frequently has any measurement of center at all. In fact, as we said with colors, there may be no even idea of what the center is because there's no ordering or range of values or anything like that. But you could say that if blue was the mode, that some people might say, oh, that's people's average favorite color. And that's why we don't use the word average in statistics, or try not to. Because in English, it gets used all over the place. And we may want to stop here. How are we doing? Yeah, we have a little bit of time left. There's like 16 more slides. We won't get through them all. Yeah, mid-range, I've already mentioned it, so we might as well look at this here because they do define it. As I mentioned before, the mid-range is the value that's in the middle of the range from smallest to biggest. And the way you get that is by taking the mean of the min and the max value, meaning you add them up and divide by 2. So if the smallest value is 100 and the biggest value is 200, then the mid-range would be 150 because that's halfway between 1 and 200. And if I take 100 plus 200 and get 300 and divide by 2, I get 150. Now this is nice actually because it's a quick, simple, calculative way to get some sense of the middle by just saying what's halfway between the low and the high end. And it only needs 2 sets of the data. You only take 2 of the data values, the biggest and the smallest, and you only do a calculation with those 2. So you can do it very quickly and easily, and sometimes by observation. But if we compare that to some of the others, maybe they'll give properties here. Because the mid-range uses only the max and min, it's very sensitive to those extreme values, so it is not resistant. So definitely, if you're only taking the biggest and smallest, then those values, those extremes become very important. In fact, you can't get much farther from being resistant than to only use the extreme values of the set. And it says in practice, it's rarely used, but it has 3 redeeming features. It's very easy to compute, as I was just describing. The mid-range helps reinforce the very important point that there are several different ways to define the center of the data set. And it's sometimes used incorrectly for the median, so confusion can be reduced by clearly defining the mid-range along with the median. If you sort of said, well, the smallest was 100 and the biggest was 200, so the median was 150, people might think the middle is 150. But if almost all the data values are between 100 and 110, then the middle should be, around 105, not up at 150, if there's only one data value bigger than that. So the mid-range is sometimes so simple that it gets used in meanings where it doesn't actually really apply. All right, so I do want to, because ordering large sets of data to find the median, adding up and dividing for our large sets of data to find the mean are things that we don't want to be burdened with. I want to make sure we have time to go look at how to do this in StatCrunch. And so I'm going to stop the slideshow there. There are more slides, looks like about 13 more. So please feel free to visit the slideshow, which you can find in the multimedia library, and continue reviewing the slides or using the textbook. But I'm going to stop the slideshow here. I'll pause to see if there are any questions before we leave it behind and before I take you into StatCrunch. So are there any questions, comments, discussions about what we've done so far today before we leave the slideshows? All right, so let's stop this share. And then let me share over here on my main screen. Okay, so I have the homework pulled up for us. So again, we are now looking into homework number 3, which is not due this week, but next week. And I think I remember question 8 being one where we have to do some calculations. So let's see if I can get that up here. Why is StatCrunch? I do not need that. Let's try that again. Number 8. Okay, so looking at number 8 on our homework, it gives us a data set, not huge, but it does ask us to find the mean, the median, and the mode, and the mid-range for the data, and then answer questions. So we are asked to find this sort of summary statistics. Summary statistics are calculations which summarize the statistics with some result. So with this set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, looks like there's 10 of them. You could just find the mean by adding up those 10 numbers and dividing by 10. Wouldn't be a disaster. But what if there was 100 of them? Pretty quickly, you're not going to want to feel that that's the way to do it. Now, in this case, notice, of course, like most data sets, they're not given in order. So it's hard for me to look at these and quickly see what's the median value. And specifically when there's 10 of them, an even number, the median value will be the mean of the middle 2. So we'd have to put them in order, see which 2 are in the middle, then add those and divide by 2. And so again, that's not a massive amount of work when there's only 10, but if there was more, that would be problematic. Now, we could maybe try to find the mode, but again, if they're not ordered in any way, then it's kind of hard to look at each number, like 205, and know, does that occur the most? I have to scan over and see how many times, then move to the next one. Even the mode can be really frustrating pretty quickly as data sets get larger. But it is good to imagine doing it yourself with smaller sets, maybe even doing it yourself on a set of this size and then matching your answer with what StatCrunch gives you so that you understand what these numbers are, how they're arrived at. That gives you a little bit better sense of what they mean. So let's get to the StatCrunch. So I would, as usual, open the data in StatCrunch. So then where do I go? What we've been looking at so far is often going to the Graph tab to graph data results. But these are not graphs. These are calculations done to get specific numerical values in this case. Oops. All right, so instead, what I want to go do is go to my other tab, Stat. So now that we are moving over to this other tab, I want to remind everybody what I said earlier, that really we're only going to use 2 tabs in StatCrunch for the whole semester, graph and stat. And we've been making use of graph already, and now we're going to start to make use of stat. And we're not going to really go to data and edit unless we try to do things more fancy. And for most of the time, you won't need to. So if I go to stat, what we've just been discussing, mean, median, mode, mid-range, these are all examples of summary stats, summary statistics. So we go to summary stats. And because our data is lumped up in one column, I'm going to go to columns. So to find things like mean, median, mode for a data set, you get the data set in StatCrunch in a column, then you go to stat, summary stats, columns. And then from here, you select the column like we did when we were making a histogram or things like that. And then there's a list of statistics here. Mean is right there near the top. And you can just click on whichever of these you want to calculate. There's a default set that have already been selected that have a bunch of the things that we're going to want. And so a simple thing to do is to just leave it and hit compute. You may get more information than you want. You can narrow this down and click on just a few things or one individual thing that you want. But if I hit compute, I get this nice list right here. So let's take a look. So it has n, which is the number of data in the set. So maybe I miscounted. I thought there was 10, but it looks like there's 11. Let me make sure I'm believing that I was wrong. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Absolutely, there's 11. So that means there is one of those data values which is right in the middle. Maybe 231. I see it a couple times. We'll see. But I can look right here. There's the mean. The mean value, when you add them up and divide by 11, is given 237 with some decimal stuff. Variance, which we'll talk about in 3.2, standard deviation, we discussed that in 3.2. So when you are doing calculations of summary statistics later in the chapter, you'll still use this same functionality in StatCrunch. You can still go into the summary stats with the columns and get things we're going to do later in the chapter as well. But here's the stuff we've been talking about recently. There's the mean, here's the median. So the median is 231. Now notice the mode is not here. So mode is not one of the ones that was selected ran automatically. I'm going to go back and edit and show you that you can, on the list, that the mode was there as well. Somewhere down here. So right there, for example, is mode. So if I click on that. Now, when you click on one of the things on the list, it just moves that over and erases all the stuff you had there. If I click on a different one, it will move that one in and replace the last one. So how can I just select ones I want? Well, you can select a range by clicking on one, hold the shift key and clicking on another, and it'll give you everything in between those. But if I want to just select specific ones, you can click on one and hit the control key, and then it will remember what you clicked on. Let's see what I want. Let's see if I go down to median, and it will just add the new thing you clicked to your list if you hit control key while you select that. So they wanted the mean, median, mode, and mid-range. So there's the mean, the median, the mode. Maybe mid-range is not on the list. Now again, mid-range is just the mean of the min and max, and the min and max are on here. But is mid-range? Range is on here, but I don't see mid-range. So what I'm going to do is I'm going to add to my little list the min and the max, and then the mid-range will be the mean of those two, or the halfway between the min and the max. All right, so then if I compute, I get just those things that I selected. So I just did a bunch of stuff in StatCrunch. So before I just type them in, let me just see if there are any questions about how to get summary statistic measurements like mean, median, mode, things like that from StatCrunch or with StatCrunch's help. All right, and I'm going to show you one other thing, because this sometimes comes up for help later as well, as becomes helpful, is that let's say instead of doing these specific things, I wanted the data in order so that I could see it in order. then I could go here on this column and say sort table in ascending order, meaning from smallest to biggest. And now it's just ordered the data for me. So then I can see that there's a couple of 205s, a couple of 231s. So why might I do that? Well, it says under mode, multiple modes. So what I'm showing you is that it does have a way to calculate mode, but it actually only does it if there's one. And after that, StatCrunch bails out. So by my having listed these in order, I can see the ones that were most frequent more easily because I can see the repetitions piling up here. You could also do the same thing by putting these, for example, into one of our earlier graphical forms like a histogram or a dot plot, where then you could just look for the highest peak in frequency for an individual value, or look where there are ties in this case. All right, so that's the basic idea. So I can go over here to mean, and I can type in, it wants that. So be sensitive now that they're asking for numerical values. Look carefully when they ask for something for how many decimals they want. So it says decimal rounded to 1 decimal place. So looking at the mean, 1 decimal place is where the 6 is. To the right of that is a 3. So I wouldn't round that up. I would leave it at a 6, and I would put in 237.6. So while we're doing these problems, you also want to develop the skills to get the answer correct without multiple tries, because your scores can go down on a quiz, or even worse on a midterm, if you're kind of like making silly mistakes and saying, oh, no big deal, I'll just do it again because it's repeatable. Well, yes, while it's repeatable, it's not a big deal, except that that doesn't portend well to your future if you don't develop the skill to try to avoid making those kind of simple mistakes. So the best time to learn how to avoid those is to recognize what you need to watch for and how to be careful before it impacts your score in a bad way. And one of the ways to do that is to look at the description of how they want the answer entered to what level of decimal accuracy. So then looking at the median value, the median was 231. So I can enter 231, and it says to round to 1 decimal place. Because the 1 decimal place is a 0, it should be satisfied without my putting it in. I could try to be extra careful and put 0.0, because then it shows 1 decimal place. It should take it either way. If it doesn't, let me know and I can adjust your score. So I'm going through this and entering answers because of these extra features that I wanted to make sure I illustrated and discussed about not only getting the answers from StatCrunch, but how to translate that to a successful check mark in your assignments online by being careful with rounding and things like that. So now it says select the correct choice below, that there is no mode. There would be no mode if all the data values occurred exactly once, or maybe they all occurred exactly twice if there was a tie where none of them occurred more than the others. But in this case, we did see there were multiple modes. And if I look, none of these occur more than twice, and it looks like 205 and 231 both occur twice. So that would be the max, and both of those would be modes. And so I would try to enter those, and I'm carefully looking to see it says, do not round, use a comma to separate answers as needed. Now, why are they saying not to round here? Well, because modes are always actual data values from the data set, and there's no reason to approximate those differently than what they were in the data set. So I would put 205, comma, what was the other one? 231. So I just entered mean, median, and mode. Let me pause there. Any questions, comments, or discussions so far? All right, so the mid-range is the value that's middle between the min and the max. So I did pull those from the set. So I would basically take the mean of those, or still avoiding the word from time to time, the average between those. I would add them up and divide by 2. So I'd get 588. And if I divide that by 2, I think I get 294. Doing math in my head is always dangerous, but let's go for it. Oh, I was wrong. Like I said, it's always dangerous. Unless they gave me the wrong median and mode. Let's see. Oh, look at this. I am curious about this. Oh, of course I'm wrong. No. It's right. I just looked at my data set and I thought the minimum was 187 and it shows 195, but that's because the 187 was moved to the left. All right, so let's see if I did my math wrong. That's probably it. I'm a math teacher after all. 187 plus 301 equals, 488, not 588. Yeah, I know my answer right there. It should be